In today's video, let's talk about how the randomized select algorithm progresses across multiple partitionings, and I will focus on which array segments still in play in each round, and how the size of the problem decreases with each partitioning step, as defined by the sequence of the sets A of j. Let's set up an example. Consider we have an array A, which is equals 8, 3, 5, 1, 9, 6, 4, 2, and 7, where we want to find the fourth smallest element. So A0 initially includes all the elements of the array A, since there's no partitioning has been occurred yet, right? So A0 is also equals 8, 3, 5, 1, 9, 6, 4, 2, and 7. And the first partitioning, j is equals 1, and we assume we randomly selected pivot, which is 5, and then we partition the whole array. The left pivot 3, 1, 4, 2, and pivot 5, and the right of the pivot is 8, 9, 6, and 7. So A1 consists of the elements still in play for the next round, which should be either 3, 1, 4, 2 or 8, 9, 6, 7, which is totally depending on the needed statistic. So the fourth smallest lies in the left segment, which is A1 is equals 3, 1, 4, and 2. And then let's do the second partitioning, j is 2. When j is 2, now the new pivot we assume which is 2. So the new partitioning is left of the pivot is 1, the pivot is 2, and right of the pivot is 3 and 4. Since the fourth smallest was in the A of 1, so we move to the right side of 2, which making A2 is equals 3 and 4. And then we do the third partitioning, which is j is equals 3, and then we find a new pivot, which is, let's say, is 3. So the partition result is left of the pivot is empty, and pivot 3, then the right of pivot is 4. So A of 3 contains one element 4 because it is the fourth smallest, because we're seeking the second smallest from A of 2, which falls to the right of the 3, right? So we get 4, right? And then let's try to analyze this sequence. So first, all the elements contained in A of 0, which contain 9 elements, and then it reduces to left of the segment, which is the absolute value of 1 is 4, and then we further reduces to the right segment. So the A of 2's absolute value is 2, and then we finally identified it, which is A of 3, the absolute value is 1. So each partitioning step effectively reduces the size of the subarray still under consideration, which dictated by the placement of the pivot. So the sequence A of j represents the subsets of A that continue to be the part of the solution space after each partitioning. So this stepwise reduction follows a pattern which is governed by the effectiveness of the pivot selection in splitting the array into smaller partitionings. So we just illustrated how the randomized select algorithm's efficiency is tied to the sequence of reducing subsets of the array. Well, each subset A of j after j's partitioning contains the elements still relevant to finding the desired order statistic. So the size of each subsequent subset strictly decreases, which assuming the effective pivot choices, thus speeding the convergence to the answer.